Hello everyone, welcome to my channel on engineering mathematics. In this video, I am going to discuss the topic of vector integration. In particularly, I will focus on line integrals. Let us first see what you will get from this video. First, I will discuss introduction to vector integration. Then, I will discuss definition of line integral, examples on evaluating line integral of a scalar field, and then examples on evaluating line integral of a vector field. Finally, I'll give you some exercise example. So let us proceed with introduction to vector integration. For that, we first recall scalar integration. In scalar integration, you integrate a single valued function, that is a scalar field, say f of x, over an interval, area or volume. For example, integration of f of x dx over the limits a to b gives the area under the curve y is equal to f of x from x is equal to a to b. Similarly, integration of rho of x comma y dv over the volume v gives the total mass if rho is the density function. Output of such integrations is a scalar number. Geometrically, it often measures the total quantity, area or accumulated effect of a scalar quantity. Now we will see definition of vector integration. In vector integration, the quantity being integrated is a vector field, that is the quantity with magnitude and direction, over a path, surface or volume. For example, integration of f dot dr over c, where f is a force field and c is this curved surface. Output of this integration could be scalar if dot or cross product is taken inside the integral. For example, work done. And output could be vector if we integrate vector components directly. For example, displacement. Geometrically, one can say it captures the effect of both magnitude and direction of a varying quantity along a domain. Now we will see what is line integration. Line integral is the concept of integrating along a curve instead of over an interval. Line integrals can indeed be classified into two main types, scalar line integral and vector line integral. Scalar line integral is represented by the integral of f of xyz ds over c, where ds represents small element of arc length along the curve or magnitude of displacement along the curve. And vector line integral is represented by integral of f dot dr along c, where dr represents the small vector displacement along the curve. Next we see examples based on scalar line integration. In this first example, we are asked to find integration of x cube y square ds along c, where c is the curve given by y is equal to x from point 1, 1 to 2, 2. Let us proceed for solution. First we label this integration some name, say I. Then we substitute the equation of the curve c given by y is equal to x in this integral I. We get I is equal to integration of x cube, and instead of y square, now I'll write x square ds along c. Next we will find value of ds in terms of dx. ds formula is under root 1 plus dy by dx the whole square dx. We calculate dy by dx from the equation of the curve y is equal to x. So dy by dx you can see is equal to 1 because derivative of x is 1. Substituting dy by dx equal to 1 here, we get ds is equal to under root 2 dx. Now I replace this ds with under root 2 dx. So this integral will be with respect to dx. So we have to write limits of this integration as limits of x. You can see in question we are asked to evaluate value of this integral from point 1, 1 to 2, 2. Here x changes from 1 to 2. So this integration will also have limits 1 to 2. So in next step we write I is equal to integration of x cube into x square. ds now is root 2 dx from 1 to 2. Let us simplify this. Root 2 is constant, you can take it out. X cube into x square is x raised to 5. Integration of x raised to 5 is x raised to 6 upon 6 over the limit 1 to 2. Substituting upper limit first, we get 2 raised to 6. Then lower limit, we get minus 1 raised to 6. 1 raised to 6 is 1. So final answer for this integration is root 2 into 2 raised to 6 minus 1 upon 6. Now let us proceed for next example. In this question, we are asked to find integration of x square y ds along c, where c is the straight line passing from point 2, 1 to 6, 4. Let us proceed for solution. If you compare this question with the previous one, you will come to know that in this question, equation of the curve C is missing. So first we find equation of the line passing through point 2, 1 to 6, 4. Let the equation of the line be y is equal to mx plus c, where m is the slope of the line and c is a constant. We know slope formula is y2 minus y1 upon x2 minus x1. Here, this is our x1 y1 and this is our x2 y2. So slope will be 4 minus 1 upon 6 minus 2, which is 3 by 4. Substituting which into this equation, we get equation of line B, y is equal to 3 by 4x plus c. To find this constant c, we have to substitute one of these points into this equation and simplify. Let me put point 2, 1 into this equation. So we get 1 is equal to 3 by 4 into 2 plus c. Solving which we get c is equal to minus half. Let us substitute value of this c over here. To see equation of line is now become y is equal to 3 by 4x minus half. Let us proceed. And now we label this integral as I. Next we substitute equation of the line that we have just found, which is y is equal to 3 by 4x minus half in this integral I. We get I is equal to integration of x square into 3 by 4x minus half ds along c. Next we find value of ds. ds formula is under root 1 plus dy by dx the whole square dx. To find dy by dx, we use equation of the line, which is this. dy by dx will be equal to 3 by 4 into derivative of x, which is 1, derivative of minus half is 0. So dy by dx is 3 by 4. Substituting it over here, we get ds is equal to under root 25 by 16 dx, which is equal to 5 by 4 dx. Now we replace this ds with 5 by 4 dx. So this integral is now with respect to dx. Therefore, we have to write limits of this integral with respect to dx. Here x changes from 2 to 6. So integral limits are 2 to 6. So in next step, we write I is equal to integration of 15 upon 16 x cube minus 5 by 8 x square dx over the limit 2 to 6. This is simplification of this previous step. Now all we have to do is we have to integrate this with respect to dx, doing which we get I is equal to 770 upon 3. I hope guys you understood this example. Now we proceed for some practice examples. Here are a couple of practice examples with their final solutions. Next we proceed for examples based on vector line integration. In this example we are given that if a force F bar is equal to 2x square y I cap plus 3xy j cap displaces a particle in the xy plane from point 0, 0 to point 1, 4 along the curve y is equal to 4x square, find the work done. This same example can be asked in a different fashion as follows. Find integration of f bar dot dr bar along C, where f bar is 2x square y I cap plus 3xy j cap along the curve y is equal to 4x square from point 0, 0 to point 1, 4. Let us see its solution. We know work done is given by the line integral f bar dot dr bar along C. In this line integral, we substitute f bar from the question, but dr bar is not given in the question. So recall that r bar represents position vector of the point whose coordinates are x, y, z. So r bar is nothing but xi cap plus yj cap plus zk cap. Therefore dr bar becomes dxi cap plus dyj cap plus dzk cap. So after substituting dr bar and f bar in this line integral, we get work done is equal to integration along C of this vector dot this vector. Taking dot product of these two vectors, we get integration along C of 2x square y dx plus 3xy dy. As we know, C is the curve whose equation is y is equal to 4x square. We have dy is equal to derivative of 4x square with respect to x, which is 8x dx. We substitute y is equal to 4x square and dy is equal to 8x dx into this integral. We see work done is now equal to integration of 2x square, y is 4x square, dx remains dx plus 3x into y is again 4x square and dy is 8x dx. Since this integral is now with respect to dx, we will use x limits. You can see here in this question, x limits varies from 0 to 1. Therefore, here integral will have limits 0 to 1. After simplifying this integrand, we get work done is equal to integration of 104 x raised to 4 dx over the limit 0 to 1. Integration of x raised to 4 is x raised to 5 upon 5. Substituting limits 0 to 1 into this, we get work done is equal to 104 by 5. I hope guys you understood this example. Now we proceed for the next one. Let us proceed for the solution. To find the value of this line integral, we substitute f bar as this vector, and as mentioned in the previous solution, we replace dr bar by dx I cap plus dy j cap plus dz k cap. So this integral of f bar dot dr bar along C becomes integral of 2i plus 3i cap plus xz j cap plus yz minus x k cap dot dx I cap plus dy j cap plus dz k cap. Taking dot product of these two vectors, we get line integral is equal to 2i plus 3 dx plus xz dy plus yz minus x dz. I hope guys you know how to find out dot product of two vectors. Next, we substitute these parametric equations of the curve into this line integral. Parametric equations of the curve are given as x is equal to 2t, y is equal to t and z is equal to t cube. So dx becomes 2 dt, dy becomes dt and dz becomes 3t square dt. Substituting all these values of x, y, z and values of dx, dy, dz into this line integral, we see line integral is now equal to integration of 2t plus 3 2 dt plus 2t into t cube dt plus t raised to 4 minus 2t into 3t square dt. Since this integration is with respect to dt, we have to use limits of t, which are varying from 0 to 1. Now, simplifying this line integral, we see integration of f bar dot dr bar value is 513 upon 70. I hope guys you understood this solution. Now let us proceed for some practice examples. These are few practice examples for you. Their final solutions are mentioned here. Please write me in comment box whether you found these solutions or not. Till I publish my next video, please watch my videos. Please do practice of these examples. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.